In the previous film, I showed the R-trig and the F-trig blocks. In this film, I will use the R-trig block in an example, a counter. Here is the example to solve. We have an input signal pulse to our program, and when we have received exactly 13 pulses from this signal, we will light a lamp, or more correctly, the output signal lamp will be true. We will also have an input signal reset that will reset the counter to 0 again and turn off the lamp or give the output signal lamp a false value. I have made a new project in Codesys. It is in simulation mode, and I have started an FBD program, a function block diagram program. For my inputs and outputs, I want to have global variables, which means that I need a global variable list. I right-click on application to choose add object, global variable list. It asks for a name. Well, GVL is okay. Now I have added my global variable list. If I want to address my global variables directly, I can remove this line. And now I can write my global variables and access them directly in my program. We needed to have the input signal pulse as a Boolean. We will also have the input signal reset, that is also a Boolean. And our output is the lamp signal, which also can be true or false, hence a Boolean. I will put my global variable list over here. And I can see it together with my program. Now I want to make a counter. I want to add 1 to my counter every time we see a pulse. I can do that here by using the AND block with the enable input. I use a block with enable, put it here, and use the add. Now I have my add block, we can see the plus sign, and with the enable input. We will add 1 when we see the pulse. And I need a variable for my counter. I want that variable to be local because it's only used within the program. It's not connected to any physical inputs or outputs from the program. Therefore, I put it in the local variable list, and I will call it number of pulses. And it can't be a Boolean because we need to count 1, 2, 3, 4. It can be an int, which is an integer, a positive or negative number. Now I can use my variable number of pulses, and I add 1 to it when we see the pulse, and the result will be a new number of pulses, which means that we will add 1 to number of pulses, and that will become the new value of number of pulses. Well, I said that we would need the R-trig block, and I haven't used that yet, but I will log in to show you what will happen without the block. I log in and accept to start a new simulation and start. And now nothing happens because we haven't got any true values in the pulse yet. Therefore, I will prepare a true value and write it, and then I will make it false again. During this short period of time, when pulse was true, the block was counting 44 times. And that is because it is counting once per scan cycle while this signal is true. Therefore, we don't want this signal to remain true. It should only count once when the pulse becomes true, and then again when the pulse becomes true the next time. I log out because I want to add the trigger block. I can find the trigger block here. In my function blocks, we can see the rising edge here. Drag it and drop it. You can see that it needs a name. I can just choose this name if I want to, hit enter, and get the possibility to auto-declare as an R-trig. Now we can try this again. I will log in. I want to log in with download because, well, we didn't have 44 pulses yet. And logging in with download will make us start from the beginning again with 0. Everything is false and number of pulses is 0, and I can start. Now I will make my pulse true, false, a number of times here. Keep an eye on the number of pulses. It shouldn't be 44. Now I have 3 pulses. I make the pulse false again and true again, and now I have 4. and this does not continue counting even though pulse is still true. I log out because I wanted to do something with those pulses. When the number of pulses is 13 or more, the lamp should be true, and then it will become false again when number of pulses is 0 again. We can do this by using a latch. Use the RS latch, drag it and drop it. We need a name here as well. I will just use the suggested name, and here we can put the lamp. For that we need an assignment, and I can write my global variable lamp. We will set the lamp when number of pulses is equal to 13. The equal to is here in the math operators here. Number of pulses is equal to 13. Then lamp will be set, and it will be reset by the reset signal. The reset signal will also set number of pulses to 0. We can do that by a move block. If I just grab the move block from here, it will have the enable input, because that is what we most often want to have. When we have the reset signal, we want to write 0 to number of pulses. This is one way of doing it, using the RS latch. You can also use the greater than or equal to block. You can put that down here. Number of pulses is greater than or equal to 13. Then another variable, not lamp, because we don't want to write to the same variable twice. Make a new assignment and the new variable name, lamp2 for example, that is another global variable. And this is enough, because as long as the number of pulses is more than or equal to 13, this signal will remain true. And then when we reset the counter to 0, this is not true, and the lamp2 signal will become false. We can try both. I log in, and I will use online change because I have already 4 pulses. Then I don't have to add that many to come to 13. Pulse is true, number of pulses is 4. And I will make this signal false, true, a number of times here. Now we have 12 pulses. We'll make one more, and hopefully both lamp signals should be true. And they are. I will make one more pulse. Now we have 14. Both lamp signals are still true, but here we can see that the set input here is false because 14 is not equal to 13. But here we have true value because 14 is more than 13. We'll make the pulse false and try to reset with the reset signal. Seems to work. Both lamp signals are false. Now if I try to add some more pulses, we can see that nothing happens, and that is because reset is still true, and we are writing 0 to number of pulses each time we're executing the program, which means that number of pulses will be 0. If we want to do this only once for reset signal, we will need to have a trig block here as well. Or maybe we want the reset signal to make the program not see the pulses until the reset signal is false again. There are a number of other applications for the RTrig and FTrig blocks, and we want to have them when we need to see a signal only once.